discuss with you about the square root of a number, and it was based on Mathematics 7, Module 1, Module number 6. This is from LRMDS Bulacan. Credits to the author, language reviewer, content editor, illustrator, and layout artist of this module. Hi math lovers! Are you ready? Let's learn! Have fun! Because mathematics is fun! What I need to know. This module has different activities that will help you in understanding the square root of a number. It will also help you in differentiating rational and irrational numbers. At the end of this module, you are expected to describe principal roots, identify whether a radical number is rational or irrational, determine between what two integers the square root of a number is. What I know. Turn your module to page 3. Let's answer our pretest. Identify whether the following statements are true or false. Write true if the statement is true and false if it is not. What's in? Let us recall that n squared is equal to n times n, which means that n multiplies itself twice. Now let's insert the figure, then find the pattern. In our figure 1, we have one box or one square. In our second pattern, we have 2 by 3 squares, or we have 4. In our third pattern, we have 3 by 3 square, or we have 9 squares. And then we have 4 by 4 squares. Yes, we have 16 squares. Now what is the next number? Yes, we have 5 by 5 squares, or 25. Practice your skill by filling out the products below. Let's use the given diamonds. We have 1, 2, 3, 4, 5 diamonds. For our first diamond, we have 1 squared. What is its value? Yes, we have 1. For our second diamond, we have 2 times 2. Yes, that is 4. For our diamond number 3, we have 3 times 3. Correct, that is 9. For our diamond number 4, we have 4 times 4. Correct, that is 16. For our fifth diamond, we have 5 times 5. Correct, the answer is 25. Now try to give the value of the following diamonds. First, we have 6 square. Correct, 36. Second diamond, we have 7 square. Correct, that is 49. Diamond number 3, we have 8 squared. We have 64. Fifth diamond, we have 9 squared. The answer is 81. For our final diamond, we have 10 squared. Correct, that is 100. let's try this one. 11 squared. Correct. 121. Next diamond, we have 12 squared. Correct. 144. Next diamond, we have 13 squared. Yes, we have 169. Next diamond is 14 squared. Correct, that is 196. For our last diamond, we have 15 squared. Correct, that is 225. Notice that all products are called perfect square as the result of squaring a number. Be careful whether or not the negative signs are inside the parentheses because they yield to different answers. Observe the differences below. Let's use this truth table to identify the differences. For our first example, we have negative 3 squared. We can express this one using negative 3 multiplied by negative 3. What will be our product? Correct, that will be 9 or positive 9. In our next example, we have negative 3 squared. We can express this as negative multiplied by the product of 3 and 3. Our answer is negative 9. Then we have negative 4 squared, expressed as negative 4 multiplied by negative 4. We have 16 or positive 16. But if we have negative 4 squared, we have negative multiplied by the product of 4 and 4. And the product is negative 16. Now we have negative 5 squared. We have negative 5 multiplied by negative 5. The product is 25. But negative 5 squared, we have negative multiplied by the product of 5 and 5. The answer is negative 25. In our last example, we have negative 2 squared, expressed as negative 2 times negative 2. The answer is positive 4 or 4. But if the given is negative 2 squared, we have negative multiplied by the product of 2 and 2. Then the product is negative 4. What's new? Turn your module to pages 3 and 4. Let's answer the word problem. Online selling has been one of the sources of income of many people, especially during the pandemic. One day, an online shop offers a limited stock of a wristwatch that shows a mathematical concept. Now, the question is, will you avail this kind of watch? Can you tell the time when people ask you about it? What time is shown in the wristwatch? What kind of numbers are they? These are what we call square roots. Based on the wristwatch, what can you get when you take square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of 49, square root of 64, square root of 81, square root of 100, square root of 121, and the square root of 144. Let's give the square root of the following numbers. The square root of 1 we have, correct, 1. Square root of 4 we have 2. Square root of 9 we have 3. Square root of 16 we have 4. Square root of 25 we have 5. For square root of 36 we have 6. Square root of 49 we have 7. Square root of 64, yes, 8. Square root of 81 we have 9. Square root of 100 we have 10. Square root of 121 we have 11. And lastly, the square root of 144, we have 12. What is it? Lesson number 1. Principal roots. First, let's have the definition. This symbol is called radical sign. The square root of b is written as square root of b, where b is called radical. Also, the negative square root of b is written as negative square root of b. Now let's have principal roots. A number has two square roots, one positive and one negative. A non-negative square root is also called principal square root. Let's have example number 1. What is the square root of 4? We have two roots. We have positive 2 and negative 2. This is because both give the answer of 4. 2 squared or 2 times 2 is equals to 4. Negative 2 times negative 2 is also equals to 4. Example number 2. What is the square root of 25? We have two roots. We have positive 5 and we have negative 5. This is because both give the answer to 25. 5 squared or 5 times 5 is equals to 25, while negative 5 squared is also equals to 25. Take note, in this lesson, we will only take the principal square root of a number, which are the positive numbers. Therefore, the principal square root of square root of 4 is 2, and for square root of 5 is 5. Lesson number 2. Classifying the principal square root as rational or irrational. First, let's differentiate rational and irrational numbers. Here is Kagura and Yushin to help us to differentiate the rational and irrational numbers. First, Kagura will identify the rational numbers. It is when radical is perfect square. We have our example. Square root of 4. Yes, we have 2 times 2. The square root of 9. Yes, that is 3. Square root of 25. Yes, we have 5. The square root of 100. That is 10 times 10. That is equals to 100. Now, Yushin will help us to identify irrational numbers. Irrational numbers are radical, that is not perfect square. We have the square root of 3, the square root of 7, the square root of 26, and the square root of 200. These numbers has no perfect square. Thanks, Kagura. Thanks, Yushin. Now let's try another representation. Let's use this table. We have the value and the principal root. Square root of 1. Rational or irrational? Correct. That is irrational, since 1 squared is equals to 1. Next is square root of 36. Rational or irrational? Yes, that is rational, since 6 squared is equals to 36. Now let's have the square root of 49. Rational or irrational? Yes, that is irrational, since 7 squared is equals to 49. How about square root of 1/4? Yes, that is rational, since 1/2 squared is equals to 1/4. Now let's try the second table. We have square root of 2. Rational or irrational number? Yes, that is irrational, since 2 is not perfect square. Now we have square root of 5. That is also irrational since 5 is not perfect square. How about square root of 19? Yes, that is also irrational since 19 is not perfect square. Now how about square root of 3 over 8? Of course, that is also irrational. Lesson number 3. Determining between what two consecutive integers the square root of a number is. If the principal square root is irrational, the exact value of the roots cannot be determined. But we can identify between what two integers the square root of a number is. Let's try to use the number line. The numbers above the line are radicals, whose corresponding square roots are those below them. It is very important that you are familiar with these expressions in determining as to between what two numbers or radicals is located. Let's try using the number line in answering the following examples. Between what consecutive number is square root of 6? Now let's use this number line. Square root of 6 is located here. On the number line above shows that square root of 6 is between the radicals square root of 4 and the square root of 9. The roots of the square root of 4 and the square root of 9 are 2 and 3 respectively. Therefore, square root of 6 is between 2 and 3. Now let's use this example number 2. Between what consecutive numbers is the square root of 50? Again, let's use this number line. Square root of 50 is located here. You can see that the square root of 50 is between square root of 49 and square root of 64. Solving for square root of 49 is equals to 7 and square root of 64 is equals to 8. Therefore, square root of 50 is between 7 and 8. If you are having trouble following the first method, you may want to try these simple steps as an alternative solution. Step 1. Think of the nearest perfect square that is less than the given radicand. Then find its principal root. For step 2, identify the next number after your answer in step 1. Let's have example number 1. The square root of 5 is between what consecutive numbers? Step 1. Think of the nearest perfect square that is less than the given radicand. Then find its principal root. 4 is the nearest perfect square that is less than 5, and square root of 4 is 2. Step 2. Identify the next number after your answer in step 1. 3 is the next number after 2. Showing this on a number line, we have. Therefore, our answer is square root of 5 lies between 2 and 3. Now let's have example number 2. Square root of 42 is between what consecutive numbers? For step 1, think of the nearest perfect square that is less than the given radicand. Then find its principal root. 36 is nearest perfect square that is less than 42. And square root of 36 is equals to 6. For step 2, identify the next number after your answer in step 1. 7 is the next number after 6. Showing this on a number line, we have. Therefore, we have square root of 42 lies between 6 and 7. Example number 3. Square root of 300 is between what consecutive numbers? For step 1, think of the nearest perfect square that is less than the given radicand. Then find its principal root. 289 is the nearest perfect square that is less than 300, and square root of 289 is 17. Step 2. Identify the next number after your answer in step 1. 18 is the next number after 17. Therefore, square root of 300 lies between 17 and 18. Now, are you ready to answer your module? Good luck! What's more? Independent activity number 1. Turn your module to pages 8 and 9. Determine if the following radicals are perfect square or not. Put a check on the column that corresponds to your answer. Independent assessment number 1. Turn your module to page 9. Write R if the number has rational square root and I if it is irrational. Independent activity number 2. Turn your module to pages 9 and 10. For test A, draw a smiling face on the circle if the pair of numbers are equal, while a sad face if not equal. For test B, draw a line to connect its radical to its correct root. Independent assessment number 2. Turn your module to page 11. Find the value of each expression. Independent activity number 3. Now turn your module to page 11. Determine between which two numbers each radical is located. Then plot it on a number line. Independent assessment number 3. Turn your module to page 12. Determine between which two consecutive integers the given square root lie. What I have learned. For what I have learned, turn your module to page 12. Let us summarize what you have learned by completing the statements below. What I can do. For what I can do, turn your module to page 13. Read and analyze each problem carefully. Write your answer on the box. Assessment. Turn your module to page 13. Let's answer our post-test. Write the equivalent expression on the numbers below. Choose your answer from the box. Additional activity. For additional activity, turn your module to page 14. For test 1, use the points on the number line to answer the questions below. For test 2, choose which radical matches the given. Write only the letters corresponding to your answer. References. Study time! It's time for you to answer your module. Thanks for watching!